The derivatives with respect to time that we've started looking at most recently often come up in their most useful forms in story problems, real life kinds of examples. And we're going to be looking at a number of examples of those types of things. The basic idea, though, is that anytime you're trying to figure out the rate at which something is changing, you're basically trying to figure out what is its derivative with respect to time. And so that's what we're going to be dealing with in this situation. Go ahead and read through this problem, pause the video while you do so, and then we'll take a look at how to actually work through it together. All right, so now that we can see what's going on in this problem, there's all sorts of different things. We got two different rates, we got two different lengths, and all of this just in a simple rectangle. A great way to be able to deal with these kinds of problems is to make a drawing. So this is the drawing I made here where I drew my rectangle, and I'm wanting to show that the height is decreasing. Now I want to get specific about that. I'm going to go ahead and label it as decreasing at 3 centimeters per second. And then the width is increasing. It's increasing at a rate of 5 centimeters per second. All while the height is already known to be 10 centimeters and the width is known to be 21 centimeters. And we want to figure out how is the area of the rectangle changing. So is it increasing? Is it decreasing? How quickly is it increasing or decreasing? And that's what we're going to be able to figure out through this. Now, I also created a little bit of a Desmos visualization for this. So if you click the link that's in the description of this video, you can go ahead and pause the video right now, go click on that link, and it'll show you what this actually looks like as we make the width bigger or smaller. All right, so taking a look at this problem, the first thing we need to do is we need to start by figuring out what an equation is to represent the starting situation. Since this problem is taking a look at area, we want to be able to write an area equation then. And of course, this is looking at a rectangle, right? So we know how to find the area of a rectangle. Area equals length times width. In this case, we didn't call it length times width, we called it height and width. So I'll call it H times W. All right, now remember, we want to figure out the rate. That means we need to find the derivative with respect to time. So now we do our derivative with respect to time. So that's going to give me dA over dt equals, and notice on the right-hand side it's H times W, so that means product rule. So we're going to do original times derivative plus derivative times original. Now that we have that, we can start plugging in the stuff that we know. Now, in this case, we have dA over dt to start with. Notice that's not anything we have, which makes sense because that's actually what we're being asked to find. We're being asked to find what is the rate at which the area is changing. That's what dA over dt means. So first thing, I put in my dA over dt, and now I start filling in the other things I know. So h, I do know what the h value is, the height. This is the actual height of it, not the rate at which it's changing, so that's going to be the 10. And then dW over dt, so this is how fast the width is changing. The width is changing by 5 centimeters per second, because notice it's getting bigger by 5 centimeters a second. We know that from right over here. All right, so then plus dH over dt. Now this is actually a spot where you could possibly run into a little stumbling block, because you'll notice that our height is changing by 3 centimeters per second, but it is decreasing by 3 centimeters per second. And so we are going to say that that is a negative 3 for dH over dt, because the height is decreasing over time. And then times W, my width, I know that's going to be 21. Now it's just a matter of actually doing the arithmetic there on the right-hand side. And so the 10 times 5 would be 50. The negative 3 times 21 is negative 63. So then 50 plus a negative 63 would be negative 13. Now, we're talking about a real situation here. We have units involved. Let's make sure we include units in our answer here. And so we're talking about the area. It's dA over dt. So the first thing we do in our unit is we put down the area units. Everything here was in centimeters, so area then is going to be measured as centimeters square, or square centimeters. And then that is over whatever the t is measured in. In this case, our t was measured in seconds. I know that because it was 5 centimeters per second and 3 centimeters per second there. So that's how I know what time is. And so what this tells us then is that the area of this rectangle at that moment is decreasing by 13 square centimeters every second. Now, if you went and played with that Desmos visualization, you'll notice that it has some different extremes. Depending on where we are in the particular dimensions of the rectangle, sometimes it's growing, sometimes it's shrinking, all depending on where you are in that whole flux. If I had started out with a really small width, it might be different, or a really big width, it might be different. So just realize that we really did need to use all of these different variables in order to be able to figure out exactly how that area was changing. Now, this was just the very first example that we've seen about related rates. These types of problems where we are going to be figuring out what's the derivative with respect to time by first interpreting the story problem. The basic idea behind all of these is the same. Write an equation to represent it. Then, because we're trying to find the rate at which it's changing, find the derivative with respect to t. Now, some of them, though, can get a little bit tricky. So I'm going to be also putting up a number of different videos with different examples in them so that you can look through those and see exactly how it worked with each of those. Do those as you wish. So if you go in and start doing the assignment and you find that, hey, this is just cruising, I totally got this, no problem, then you're doing fine. But if you're running into some trouble, then go find a problem that's like that and watch the video on that so you can kind of get a walkthrough about how to approach that sort of problem as well.